Then I play.
Hello. Thank you for inviting me to give a talk at your conference. I wish I could be there with you in person, but as it is, greetings from Australia. Though being 11:30 p.m. at night, I guess this is more appropriate. Forgive me for what may be a fairly self-indulgent talk, but I think this is very much a talk for these times. When I was first invited to give a talk for this symposium, I wasn't quite sure what I could talk about. I definitely believed that I had the credentials to talk about software sustainability from my experiences as a programmer, starting as a PhD student by programming analytic gradients for the Bruckner doubles variant of the couple cluster method into CADBAC, through postdocing in Dalton and NWChem, and currently programming within the Gaussian platform, but also through my former role as academic consultant at Australia's National Supercomputer Centre, which I had been in since 2001. In that time, we used to deliver training courses where advanced programming was looking into profiling and code optimizing through MPI and OpenMP. Now, that course just deals with compiling and linking programs. I mean, when did Make become advanced programming? So there is a very real crisis in Australia at the moment with where are the programmers? And finding a programmer is much harder than finding Wally. I think this is reflected around the world, but more so an issue with Australia, because even if we think we are at the top of the world, the tyranny of distance is such that it is difficult for Australia to engage with a wider program developing community. The shortage of programmers does not surprise me, as from my experience it is very difficult getting an academic job due to lack of publications. I spent 2 years in my PhD programming up BDT and its analytic gradients for only 2 papers, a year on NWChem to get 1 paper, and many of my programming friends will tell the same story. I think the US recognized this by putting money into the Molsey Institute, but we couldn't convince Australia to do something similar, even with the involvement of Peter Gill, Mick Collins, Peter Taylor, Alistair Rendell, Julian Gale, Roger Amos, and myself. Pretty good programming pedigree, I think you'll agree. Unable to get myself an academic position, but wanting to be involved in teaching, I joined the organizing committee of the Virtual Winter School on Computational Chemistry, an annual fully virtual event consisting of lectures, poster sessions, and workshops to computational chemistry students from all around the world. So my talk was going to be about how to raise the next generation of programmers from my experience at the Supercomputer Centre, observing changes in programming practice across the various scientific disciplines in Australia. That was going to be my talk. But then COVID-19 struck, and suddenly my winter school colleagues and myself were inundated with requests for advice on how to organise online conferences and best remote teaching practices. One such initiative was a symposium organised by some astronomers at CSIRO exploring the future of meetings. Knowing I had relevant experience from winter school, a friend on the committee asked if I was interested in being involved. The idea for the symposium actually began last year within a group of astronomers who were looking into more effective remote collaborations to reduce their carbon footprint. Apparently, they found statistics showing astronomers had the biggest carbon footprint of all the scientific disciplines. However, when COVID struck, interest in the symposium exploded with people registering from all walks of life, many unexpected, looking to us for best remote working practices. The symposium grew from exploring the future of scientific meetings to the future of how we work, educate, collaborate, and interact. It became a truly cross-disciplinary symposium, encouraging us to explore key themes and share ideas from a variety of people and perspectives we don't normally interact with. We were very fortunate that companies we believed would shape the future, such as Atlassian, Slack, Fujitsu, Microsoft, and many others, wanted to be part of our conversation. I learnt a lot. And if you are interested, even though the symposium is finished, the website is still available for a while. Just go to this link to register to access the material. One part of the symposium was a series of panel discussions on various themes: lessons learned from virtual interactions, more inclusive virtual interactions, technology to help us collaborate virtually, how to effectively communicate and collaborate virtually, virtual or not virtual, That is a discussion. And the one on technology to help us collaborate virtually inspired me to present this talk today. The cross-disciplinary nature of the symposium opened my eyes to a whole new world of remote working tools. There are many such slides, of which I have chosen this one from a blog by Frederica Wengi. Now, a lot of these tools, which you may or may not recognize, aren't really suited to what I want to talk about, but I like the thinking behind dividing them into asynchronous and synchronous, especially important when dealing with time zones, and mimic reality versus digital native reality, arising from a start point of substituting real interactions with their virtual equivalents. Also, while talking to vendors, we also discovered just how rapidly COVID made companies reinvent themselves and repurpose their tools. The famous example being how Zoom went from a video meeting tool to classroom, place of worship, fitness center. More on that later. So what are the relevant tools for this audience? Without a doubt, the start point would be GitHub, GitLab, Bitbucket, and the like. These describe themselves as code hosting platforms or version control repositories. Probably everyone here uses one of these. This is definitely asynchronous collaboration, where people clone their repository, make modifications to their local copy, and then commit their changes. What about synchronous? I was introduced to REPL when I found myself on an Amazon Web Services panel on transitioning to remote learning. I've been interested for a while in the problem of running hands-on computational chemistry workshops when most universities in Australia and some around the world were moving their classrooms to the cloud, even before COVID-19. Cloud providers don't see the problem, but for the chemistry students I was teaching, there was the issue of how to handle licensed software, but more so, I was introducing basic Python programming into chemistry students as part of a second-year thermodynamics and quantum mechanics course. Many of them weren't interested in computers, and they certainly didn't want to become sysadmins. I started off by using CoCalc, which was a cloud-based course management platform, but ultimately was hampered by not being able to install non-standard Python modules. My fellow experts on the panel recommended REPL, which is described as an interactive programming environment. This didn't really address my issues, but it did really intrigue me. Recent work I've done has been in Gaussian and a bit of modification of Jeff Reamer's copy of VASP, neither of which we use repositories for, it not really being our code to do so. Merging together all our changes, and there were 3 of us working on this VASP modification, took a bit of work. And I know the theory with GitHub, etc., of working on up-to-date local copies and continuous integration, but I found in practice it's not always smooth to keep these changes in sync. So for REPL, I'm thinking Google Doc and Overleaf. I would love to see whether this could work for larger software packages. And speaking of workshops, the symposium hosted a few workshops which introduced to me the concept of digital whiteboards such as Mural or Miro. Now, I'm a huge fan of whiteboards, but as these appear to be mainly used for sticking post-it notes on, I'll move on to something that is more of interest to me and possibly you as a scientific audience. One of our contributed talks was by Andres Ramos, an astronomer from the Netherlands. He was a firm believer that the future lay in what he called virtual research environments, also known as science gateways, virtual laboratories, and I've also heard them described as research hubs. He gave some examples and gave a case study on snail reproduction. For this audience, the relevant one would be NanoHub, but I'll also add the Galaxy Bioinformatics project as something that was brought to my attention, and my personal favorite, AIDA, a framework for high-throughput computational workflows from the Materials Cloud community in Europe. All these virtual research environments have in common is that they have a web interface to an integrated infrastructure of software tools, data, and HPC resources, and are supported by a distributed community, some spawning their own regional hubs. However, these all appear to be focused on sharing and running tools. I haven't seen so many dealing with scientific software development or collaborative scientific software development. The software development community hubs I've seen so far, and I'm mainly thinking Docker and the like, mostly deal with deployment rather than development, which makes me wonder about Edison. At the time I'm recording this talk, I haven't got to hear the talk on Edison, but from what I've been hearing so far and their website, I'm wondering if this is the beginnings of a software development community hub. I'd be very interested in seeing how this pans out. Watch this space. These tools I have termed as being for remote collaborations. However, a recurring theme throughout the symposium were comments like, what about social interactions or Zoom fatigue? I need visual feedback like body language. I miss corridor conversations, by which they meant the chance meetings where you just happen to run into someone in the corridor and start a fruitful discussion. And this was echoed very strongly in student feedback when lectures were moved online. I'm not really a social butterfly. I'm naturally a camera off person by choice and wasn't really affected by COVID lockdown, but a large part of the symposium was dedicated to more real interactions, and a lot of people felt very strongly about this aspect, so I thought I'd look into that now. So for the rest of the talk, I would like to explore virtual collaborations with my colleague from the organizing committee, VR, AR, XR enthusiast, Glenn Reese. We had already started looking into social interactions with the winter school, where this year we decided to add a social element with virtual coffee breaks. We kept a Zoom session open for attendees to mingle during one of the breaks, encouraging them to chat to each other, but this didn't really work. I caught up with a few people, but using the chat box was not effective due to the sequential nature of chat boxes, mangling the order of conversations, and typing speed and accuracy proving a significant constraint. Next year, we were thinking of trying breakout rooms, but in the meantime, as part of the Future of Meeting Symposium, we had the opportunity to try out a variety of social events. My favorite so far has been GatherTown for its simplicity. GatherTown started off as a video calling platform, making use of spatial audio to restrict interactions. But since COVID, they've scrambled to capture the online conference market, and last I heard they want to corner the virtual office space. And there has been an amazing amount of development even since June when I first started playing with it. So the idea would be to potter around the conference tea room and find my friend Glenn. Hey Glenn.
Hey Rika.
And show him a paper I am interested in. So this is actually part of an assignment I gave my second year Python students, and the idea was to give them some structures to match with the rotational spectrum in the paper.
That's pretty cool.
But it needs equations, so we go off to the whiteboard. So I'll write the equation for the rotational constant, B equals h over 8 pi squared I, where I is the moment of inertia. And I can see Glenn can write on it too.
And we can both see it in real time. That's pretty cool.
Yeah. Okay. So this is sort of like a collaborative whiteboard, but that's not the fun part. Let's go and program this up. So we head off to my laptop, and this is basically REPL in action.
It's pretty cool.
Yeah, it is. And actually, it's real time, so I can actually modify and compile on the spot.
And you can embed pretty much anything into the screens here, right? So if it's interactable on the main program, it's also interactable for everyone on here, which is pretty cool. It certainly is. Yep. Yeah, it is. So I think that's enough work. I think we should now head out to the corridor. Oh, look, it's Vanessa. Hey, Vanessa.
Hey, how's it going?
It's tough. Come and join us for a beer.
Sounds good.
And we head out for a conference beer with Roger. Hey, Roger.
Morning, everybody. Evening, everything.
So that was fun and kind of engaging, but not a very realistic interaction. For that, we need to go to virtual reality, and there were several talks addressing that from Yvonne Rogers of University College London and her telepresence robots. I don't know if you can see, but the actual students are there on the screen. To Patrice Ray of Sydney University, who has built himself a School of Geosciences virtual campus, and I'll let Patrice tell you about it in his own words.
I've built a School of Geosciences virtual campus, which is made in a number of dorms. And each of these dorms, there is a facility. So here we have a virtual meeting room where people can visualize YouTube videos and PowerPoint presentation and PDF or any 3D models that came from the computers. There was a number of tables and or station here that give you access to whiteboard and or blackboard or corkboard. They are all fully functional. You can record, you can video record all the talks, all the activities that occur in these rooms. And you can grow that table and the number of seats, you know, as you have more and more participants entering that room. I've built practical rooms, you know, with rocks and fossils and other geology and geophysics resources.
And it is amusing to see, just as how Zoom repurposed itself, how gaming platforms started repurposing themselves to capture the remote conference, meeting, office markets. Now, at this point, this may start to feel a bit gimmicky to us old crusties. How much of this is frivolity, and can you really work in this medium? People like Patrice would swear by it, and also the younger generation, such as students, are being open-minded, such that I discovered the University of Melbourne has a learning environment using one of these gaming platforms, AltSpace. We had stories throughout the symposium how students found virtual interactions more liberating, equalizing, and empowering, especially for those who were shy or lacked confidence, being able to speak up without confronting an intimidating professor in person. But VR can be a gimmick, as Michael Barngrove said. VR must be justified. So let's dive into these spaces and go through the experience. I don't think you will get a true feeling of immersion from just a recording. You have to be there, but we'll see how it goes.
So, does it feel different? Yes, I think it does. For one thing, I can move around, which is kind of liberating. I'm not just sitting there staring at a screen. I can wave my hands around, which I kind of find comforting when I talk. And also being camera shy, I'm not so self-conscious.
We can watch talks like this one, and instead of staring fixedly at a small screen and getting screen fatigue, we can have the big movie experience. All I need is popcorn. Now, AltSpace doesn't really have whiteboard capability. It's still very much geared towards social interactions. I'm not sure how much I can do here. I'm getting over the initial feelings of seasickness I used to feel if I stayed in here too long. And many VR critics complain about the cumbersome nature of the headset, not to mention cost. But as this blog from Renji Bijoy, one of our keynote speakers, shows, the big tech giants are investing billions researching AR and launching glasses in the next couple of years.
But really, this isn't set up a collaborative work. On the other hand, if you remember Patrice Ray's virtual School of Geosciences campus, well, we asked Patrice to show us around, and this is what happened.
Would you rather it not be public?
Well, who's joined us?
Earth Mark, how are you, mate?
Hello, Neil's Monic. I'm good. How are you?
And it turns out that this guy was a programmer, a NHISS programmer from Seattle. And so when I asked him about collaborative programming, this is what he said. Can I ask you a question? This is kind of like work-related, but you were talking about hackathons. So I'm meant to be giving a talk, which is why I asked Patrice to show me, about how you can do collaborative software development. And we're sort of trying to find different ways of doing it. But I haven't seen a world where you can actually share Jupyter notebooks and stuff like that.
Well, we can do that now. GeoFix.
Any notebooks. I don't know what you
Jupyter notebooks. GeoFix.
So can you do that, Patrice?
Yeah, we can do that.
Can you show me?
Not me, but GeoFix is one of our colleagues, you know, in NHISS. Yeah, and he has designed, you know, a simple system to have Jupyter notebook in NHISS, and he can control, you know, a simple graphing systems, you know, with using.
Yeah, I'd love to see something like that.
Yeah.
So NHISS has a built-in programming language which is based on C#, but is pretty much just a. It's like if you took the AST out of a compiler and then just made that exactly what you're writing. So you can very easily write out code that it's technically imperative and functional. Like it's written like a functional piece of code, but you do that and then these are live. Well, if I can actually type worth a damn.
Mhm.
But then you can make
Well, the
these more and
software-
more complex using blocks instead of code, because text
Yes.
sucks in here. Yeah, no, this environment is really good for that, and it is a different style of development than anything I've been used to, where you pop into a world, people are even if they're not working on the same project, it's like you're working in the same IDE in different sections of code about different things. And it
And
is
also in the same office to some extent, right? Because you can just pop in and say, "Oh, what are you working on?"
It's even weirder than that, because it's like it's like you're all working on the same desktop. So you can see their other windows, and you actually can't not see them. So you see someone working who just isn't like a field of nodes, and you're like, they are deep in something. I'm not going to touch their thing. But you can tell people are lost, and it becomes a very collaborative development effort that's even more collaborative than things like paired programming, or if you're in an office, it's even more intertwined than that is. It's hard to explain.
And later, they literally dived into some more complicated bit of code.
Yeah, I'm a software developer for companies. So, we did get some tools that make that slightly easier. There's still some problems with it that I'm hoping we get changed. But then it would make those behaviors easier, where you could do isolation.
Like, you can shrink yourself down and fly yourself up and use yourself as a pointer. Like,
oh yeah, that happens a lot. People be like, this is the subsection that detects how far that you threw it.
Yeah.
And in particular, this thing right here, I think. Yeah, right here. This is where it's telling how far, or if it should trigger a throw. So, yeah, you can just like fly around in the code and be like, ooh, this arrow looks terrible. Let's go move it somewhere else. Or that was a vector input, but whatever.
So all this coding is way beyond me for the moment, but I include it as an amazing example of the serendipitous meetings people say you can only get in real life.
Sustainable software needs a strong collaboration framework. Tools are being actively developed to connect a global work community. We may have just witnessed a huge paradigm shift in the way we work, or when this is all over, we may just go back to how we used to do things. But COVID-19 opened up the world for me, and I think I'm not the only one. I have had far more interactions this year than I've had in a long while, many of them international. This is an opportunity for the collaboration network to truly grow. There is compelling evidence from stories around the world that a large percent of the workforce will continue working from home and/or have their office hours reduced. And even as I speak, today's headlines has such an article. People are saying they miss realistic interactions. Is VR, AR, XR the future? The VR community has certainly mobilized to adapt their tools for remote work and collaborations. As you see, the technology is still immature at this stage, but one can see a way forward. At least in COVID isolation, it had the benefit of being fun, if not quite practical. So we are on the cusp of a huge paradigm shift in the way we work, with the possibility of huge collaborative networks, which I think will be a good thing for sustainable software. It will be interesting to see what the future brings. Now, if all goes well, I'm hoping to be online to answer any questions. Please feel free to start a discussion. It's getting quite lonely talking to myself. Thank you.
Thank you very much, Professor Kobayashi. And looks like she is online right now to take questions. Are there any questions? Well, okay.
May I?
Like, okay, go ahead, Professor Lin.
Hello, Rika. Very good presentation. This is what my wife is talking about all the time, and the useless traveling forth and back. Now, if there is one thing you would like to highlight, which you think is mature enough for us to start use right away, what would that be? I can't hear you. You're on mute.
Yes, you should unmute yourself. Professor Kobayashi, okay.
Yes, sorry, that was a very good question.
I don't know. I think at the very first instance, I like the idea of that REPL type thing, because all the software development I've been doing, I've been fairly isolated. Like everything I've done, I seem to have done, it feels like on my own, and I just hand my software to someone and then they just sort of merge it in. None of the people I'm really working with are using GitHub and GitLab. So it has been a very sort of like, asynchronous sort of like merging thing. Whereas when I've been doing things like joint papers, we've been using Google Docs and Overleaf, where you're all working on the same thing. So I don't know if that makes more merging problems or less merging problems, but I think that would be what I'd like to see, the fact that we're all working literally on the same piece of code.
All right.
Is that the sort of
Thank
question
you.
you're asking? I mean, I would love the VR to work, but yeah, it's not mature yet, but it was fun being in that room. We were there for 2 hours just talking about programming with some random guy who turned up. And I love whiteboards, and you know, I have been doing teaching and trying to use whiteboards, but like the whiteboard in Gathertown, and it's too 2D. Sort of to be there and just use a whiteboard with people standing next to you, it just felt a lot better than just doing it through Zoom.
Right. Me personally, this share screen option, showing somebody in the code on my computer, even handing over the cursor to the other guy, actually handling my computer has been a revelation. And I think we're going to continue and work in this way a lot.
Okay, can I tell you a cute story from my teaching time? So we were trying to make things more friendly. So I had a Zoom lecture and I used PowerPoint as a background, and using Zoom annotation. At the last lecture, we actually played Pictionary. Do you know that game?
Yes.
Sure.
Yep, that's what we did. So everyone sort of like took turns drawing on this whiteboard that was basically my PowerPoint sort of like white page. And that was great fun. So yeah, shared whiteboards, fun, but really it was much more fun in VR.
All right. Thank you very much again.
Okay. And I was wondering, when I saw yesterday's talk on Edison and all those modules, that reminded me of the sort of thing that you could do. It looked like what Earthmark was doing with his sort of programming blocks. And I think that it wouldn't take much for you to do that 2D module and pipeline in 3D and walk around, just all of you sort of programmers walking around moving bits of code and collaboratively programming that way. What do you think?
That would be very nice. I think we could even add a VR on top of that so that we can just...
Yeah, that's what I was thinking, because that code that the Wolfie guy was using, I mean, that just really reminded me of your code, your modules yesterday, and it made me think.
I see, yeah. Yeah, we'll talk about that later, yeah.
Yeah, and that also reminded me of Michael's comment yesterday about making it fun for students. I don't know.
All right. Well, then that's about a wrap for this.
If I may, I'd like to ask a question also here.
Okay.
Hello, Rika.
Hello.
Nice to see you, and very nice lecture.
Thank you.
Congratulations with that clip. In the beginning, you mentioned that you couldn't find programmers in Australia to collaborate with.
Oh, yeah.
And you decided to look for them somewhere else through these systems for virtual collaboration. But what would be your thoughts how to grow new generations of programmers locally?
Okay, that is a very good question, because as I said, that was going to be my talk originally. Yes, the Australian government, I could talk ages for this, but the Australian government thought we need more programmers. So they're trying to teach all the children Python at high school. And I think this is a terrible idea, because they're learning Python, but they're not learning maths or science. So they've got no idea. I think the Australian government thinks that Python or science is just data science. It's not. It's not.
Right. So teaching them.
I think everyone's got their microphones on.
There is some kind of interference, probably. So teaching them some kind of high-level languages.
That's probably my Gathertown thing.
is probably not a good idea. But how can we make scientific computing attractive? I realize that you may not have answer right away, but
I think people in Gathertown have to turn their microphones off or speakers.
All right. All right, simply the question that we all have in mind probably how to make our branch of science, our branch of academia more attractive for younger people. Because if they always do what we have done in the past, doing Fortran programming, this leads nowhere for them, offers them no perspectives for job seeking for the job market. How can we improve the situation? That would be my question, not only to you, but maybe to many other people.
Oh, this is a big question all over the world. So I got in contact, someone, an astronomer, I think he was, or I don't know, a guy called Danny Katz. He was sort of like looking for people to try and start some sort of initiative on giving programmers more credit. Mm. And it's funny, in the astronomy world, because it's a small community, astronomers, if you write a bit of code that someone uses, you get to be an author on your paper, not just cited, an author on the paper. Mm. There's all these initiatives around to give people more motivation. That's why I mentioned MOLSI, because MOLSI, you know, they're actually legitimizing coders, but that seems to be just America at the moment. But I think, yes, if you do want to have the programmers, you've got to give them a future, because I have lost so many programming friends and I've struggled myself a lot.